All right, so I want to talk about yesterday's ODP, today's ODP. I want to talk about the midterm, and I'm not sure what else, whatever else we want to talk about. So, any questions? I want to talk about Git too, how to like unroll yourself from Git mishaps. All right, let's start with ODP 414. So this is the mix function, right? We talked about this yesterday. So mixing two strings together. So we sort of waved our hands at an algorithm yesterday in class by doing some things on paper. And the idea was have a pair of pointers for where you are in the strings and where you are in the output string. I did this with 2 pointers, one for the input string, one for the output string, so in location and out location. Because the 2 strings are the same length, and if you're reading the 3rd character from the first one, then you're going to read the 3rd character from the next. So in location is the position in the input strings, out location is the position in the output strings, and I start them both at 0. And our usual for loop, 0 to string length of the strings minus 1. And then since outloc in my mind is always the location where I should store the next character, right, I can just do out bracket outloc equals string 1's inloc. And I do a post increment on outloc, so it increments that afterwards, and then outloc plus 2 plus plus equals S2's character. And if I believe that outloc is always where the next character should be written, then when I exit that loop, outloc is where the null terminator should go. And so I can just say out bracket outloc equals null terminator. And that should mix the 2 strings together. Again, new lines are generally not anything special. Don't try to do special processing with new lines. If you mix 2 strings that both end with a new line, the composite string will end with 2 new lines. That's correct. That's what it should do. The only real special character in strings is the null terminator, right? This character 0 \0. That one's always special because it's got to be at the end of the string. But letters, digits, punctuation, new lines, tabs, spaces are just like any other character unless we say so otherwise, like if we say remove the new line from the end of a line or something. So questions on how to do this? Yeah.
I had a hard time with it.
Okay.
I don't really know. I tried to do it with a while loop instead before, but I also haven't really been using string length either.
Okay. You don't need string length if you use a while loop, actually.
Maybe I ought to. Maybe I ought to just send the code and we can discuss it outside because it's kind of.
Okay.
I feel like it's doing what it's supposed to do, but I'm missing something.
Okay. Send me an email, right? And I can look at the code you submitted for assessment. Or if you have code you didn't submit for assessment, you can send that to me, and we can talk about it. If you wanted to do this with a while loop, you could do. You still need an output location. You still need an in location. So your while would be while the character you're looking at is not the null terminator. Right, and the same thing, out outloc is first bracket inloc, and then out outloc is second bracket inloc. And then you need to somewhere, incrementer in location at the end of the while loop. And you could do that as a post increment when you use it down here, if it's in a while loop, or you can just put an inload plus plus at the end. All right, so 415. 415 is more of a fun ODP. So we're writing a function named calc, as in calculate. It takes a character array that's a string and it returns an integer. And what it actually does is it evaluates the character string as an arithmetic expression. Okay, simple expression, basically a number, an operator, and a number, where the numbers are integers, and there's no spaces anywhere in the string. And the operator is either plus, minus, star, or slash for add, subtract, multiply, and divide. And your function should do whatever that string asked it to do. If it's 2 plus 3, it should calculate 2 plus 3 and return 5. So it's a little calculator function. And so you should parse it using scanf, using the pattern %d, %c, %d. Okay, an integer followed by a single character followed by an integer. And remember, if you match an integer, you have to do ampersand, name of a variable that's declared as an integer. If you do %c, that's a character, you have to match it with an argument, ampersand variable that's declared as a character. Okay, strings are the only time that you don't need that ampersand. And we're not doing strings here, we're doing a character. So a scanf of a single character would be something like whatever your string is, %c address my character, where somewhere you said character my char. And if you say character star my char, or if you say my char without an ampersand, or you say my char bracket 0 or anything like that, it's like going to a foreign language and just shouting out something random, going to a foreign country. No telling what it's going to do. Okay, doesn't matter that you want this to read a character into a character. Those things significantly change what happens, right? If this is a car star, you're going to seg fault. If this has not got an ampersand in the front, you're going to seg fault. So characters are basically integers, right? We use a %c instead of a %d, but you still need that ampersand in the front, and you declare them without an asterisk. Okay. Generally, asterisks are only for strings for this course. We'll change that a little bit later on. But okay, everybody okay with that? And if you're not sure, if you've never used scanf with a character, write some code first and just practice with it. Just make a string and try to convert it to a character using %c, and watch where it puts things in and so on. Okay, so your function is supposed to take a string, calculate the value of that expression in the string, and return that as an integer. If you cannot parse the string, return -1. If it's not a %d, %c, %d, return -1. Okay, if it is in this format, but this operator, the character in the middle, is not plus, minus, star, or slash, return -2. So there's two possible errors here. Either it's not an integer, character, integer, or it is, but the character is not a valid operator. Okay, so two different error codes. Test it and then assess it in the usual way. So I put some test cases down here, just to give you an idea, okay? And the angle brackets are not part of the string. They're just on there to show us what the string is. So if the string is 9 plus sign 9, the function should return 18. If it's 9 equals 2, that's an int, character int, but equals is not one of our operators, that's error -2. Ha plus ho, those are not integer, character, integer, so the error is -1, and so on. Division, just use what bash does for division, which means it truncates. So 9 divided by 8 is going to give you 1. 8 divided by 9 will give you 0. Okay, if you do $paren, sorry, we're not bash, we're C. Integer division truncates. So 9 divided by 8 gives you 1, 8 divided by 9 gives you 0. Yeah.
So like 2 minus 3 also returns minus.
Also returns -1. Yeah, yeah. So it's an imperfect error code. Yeah.
What if we attempted to divide by 0?
I won't. I imagine your code will print an error message. That's okay. I won't use that as a test case. Clear? Any questions on how you're going to do this?
Yes, I am.
Okay. Well, imagine that someone hands you a string. With 5 characters in it, 4, 5, plus sign, 1, and 7. And they want you to do what this ODP is asking, right? Just you yourself, right? Somehow you would need to look at this and decide this is one integer, and this is the operator, and this is another integer. Yeah, thanks. So someone says do 45 plus 17, right? Somehow you need to say this is the first number, 45, this is the operator plus, this is the second number, 17. Okay? Once you've done that, right, you've got 2 numbers, 45 and 17. You need to look at this and say, well, if it's a plus, I'm going to add these, and you'll do the addition and give them. If this is a star, I'm going to multiply them. You'll do the multiplication. If it's not a slash or a minus or a plus or a star, then you're going to say error, right? So the trickiest part maybe is how do you decide this is a 45 and this is a 17 and this is a plus? That's what scanf does for you. So if you scanf whatever the input is, %d, %c, %d, address number 1, address operator, address number 2. Make sure this returns 3, right? Because we're trying to extract 3 pieces of information from here, integer, character, integer. And we're trying to write 3 variables with those extracted pieces. If it returns 3, then that's exactly what it did. If it doesn't return 3, then for some reason it didn't find 3 things to extract. So that's an error right there. So if this returns 3, well, now number 1 and number 2 are our numbers. Write an if statement. If the operator is equal to a plus sign, then return num1 plus num2. Right? Or you can use a switch statement if you like switches. And characters, so if our character is called OPR, same thing like we did when we were counting E's. If operator equals equals single quote plus sign, that'll tell you if it's a plus. Watch out for the double quotes and such. And if you have 4 of these, plus, minus, times, divide, and it's not equal to any of those, right? If you do an if else, the last else would be else it's not one of those, that's an error. And return the appropriate error code. All right, other questions on this?
This isn't necessarily to do with the ODP all the way, but like if someone were to write out the word 4 and then plus and then the word 7, is there anything in C that you can make the word 4 equivalent to the integer 4?
Not in like regular C that you would normally get. But you could, so for single digits, right, what could you do? You could make an array containing 10 strings, O-N-E, T-W-O, T-H-R-E, and you could make a function that loops through and compares your string to each of those things in the array. And if it matches the 5th thing, then it returns a 5, saying, oh, that's the number 5. But then it gets harder with things bigger than 9 because we got all these weird rules. But you could write something like that. That would basically take a long version of a number and turn it into an integer. That could be a nice piece of an SLP, actually. It's a nice launching point for something that like interprets written text. But yeah, I don't know of a built-in that does that. All right, other questions, worries, thoughts? All right, let me talk about Git. There will be a Git question on the midterm. It's worth 8 points, so you can get yourself an easy 8 points and make your life better if you make peace with Git in the next few days. So let me do a quick run through on some Gits. In particular, I've talked about how to do Git. I haven't really talked a whole lot about what to do when things go wrong, and things go wrong. So I want to look at what you can do if something has gone wrong, and also how you can help verify that like things are not gone wrong, right? That things are where they should be. So I'm on the Linux server. What should I pick on? All right, I'll pick on my Verilog directory. If I do an ls-a, that will show me all my files, including hidden files. If I see a .git, it means I've got a Git repository here. And I'm pretty sure I've never put this directory under Git's control. But I did an ls-a just to check there's no .git in there. And if I say git status, it says it's not a Git repository. Okay, so this is a clean directory. This is where you want to start all of your projects, right? Make dir some directory, cd into that directory, and just start working in there. All right, so clean repository. So first time you want to initialize a local Git repository, it's just one command, git init. Okay, and you do that once per directory. So now if I do an ls-l, I see a ls-al, I see a .git in there. And if I say git status, it tells me that it knows about this directory. If I think I'm starting a new project, but I'm actually in a directory that I've already been using for Git, and I say git init, I get this message, reinitializing existing Git repository. That's a warning sign, okay? Unless you really, really intended to do that, it means you're in somewhere that you've already been doing Git, okay? Which means if I was doing PA1 in here, and I pushed it over to GitLab and so on, and now I'm doing PA4, and I'm in somewhere where I already have a repository, chances are when I try to push it over, it's going to want to go into PA1, right? And that's one way that things get lost and things get confused. So always start in a clean directory, okay? So I'm in this directory, I just put it under Git control about 3 minutes ago. I'm good to go. Okay, I have 4 directories in here. I just want to put everything in here under Git, okay? I'm just going to say git add star. And if I say git status, it shows me that I've got all these files in these different directories. So this is called putting them in the staging area, right? This does not actually push them into the repo. When you say git add, you're adding them to the staging area, okay? To actually put them into the cache, you have to commit those changes into the repo. So that's what git commit does. So if I say git commit, it asks me to put in a message, initial check-in of all these files, okay? And now they've been pushed into the staging area. This is all still local. Haven't done anything on GitLab yet, okay? So now if I make a README, so I've got some random README in there, and I want to add that to the repository. 2 steps. Put it in the staging area, and then commit your changes from the staging area to the repo. So again, it's just git add readme and then git commit. Alright, and anytime that you make changes to files, anytime you add new files, git add, git commit. If you change an existing file, it's still git add, git commit. Okay, add just adds it to the stage, and commit takes it from the stage, puts it in the repo. So even if it's a file that you've done this to 100 times, if you make one change to it and you want to put it in the repo, you got to add it to the staging area and then commit that. Okay, so this is all local. I haven't done anything on GitLab yet. Time comes, I want to push this over to GitLab, and I want to call my GitLab repository, I don't know, I'll call it Sunday. So this is where you do this one-time operation, git remote add origin git at gitlab.com colon username. I don't think case matters, but I never know. And then the name of your repository .git. I think my name's actually lowercase, but I don't think it matters. Okay, that sets up this association between my local repository and GitLab, but it hasn't actually pushed anything over yet. When I want to push something, that's when you say git push origin master. Okay, and that's done two things. It's created the repository on GitLab, and it's pushed my local repository over to that remote one. Okay, if this repository had already existed, if I had gone to GitLab and created a repository called Sunday, this would give me an error. Okay, so you want to be working with a clean repository, clean directory. Okay, now if I make a change to a file, right, and I want to add it to my local staging area, commit my changes to my local repository, right, that's still on my local side. Now if I want to push that over to the remote server, just git push origin master. Alright, so that's if everything works the way it's supposed to. So what can go wrong? I'm starting some new project, but I don't like changing directories. I do everything from this directory, but now I want to start a project called PA4. So I write pa4.c, and I say git init, and I ignore that, and I say git add pa4.c, git commit, and then I say git remote add origin git at gitlab.com nicomacias /pa4.git, and I get the dreaded error message, right? And that tells me that either pa4.git exists, or I'm sitting in a directory that I've already done this before, right, which is the case here. I'm in this directory that I already linked up with sunday.git, and now I'm trying to link it up with something else. Okay, that's a warning sign. So here's what I suggest, right? Make yourself a new directory. Copy your files over into that new directory. So now I'm in this totally new PA4, and all I've got in there is the file that I wanted, and just start the process clean. Okay, git init, git add pa4.c, git commit, and then git remote add origin. Oop. And then git push origin master. And if you're doing something where you created a repository on GitLab by mistake, I recommend just go in and delete that. Make sure you have the files on your Linux server. But go into the project and delete it. Right? Go to the settings, go to the bottom where it says advanced, go to the bottom of that, and there'll be a thing for remove the project, and it makes you type in the name of the project to confirm that you want to delete it. And then you're back to a clean slate. All right, questions about that? Yeah.
If you want to remove a directory as the origin, would you just delete it? Or how would you do that?
So as far as I know, GitLab has no idea on its side that I linked a particular thing to a particular repository. So if I go to another directory and I link that, it should work fine.
Okay.
So yeah, if you go in and you just remove the directory in question, right, you should be able to go somewhere else and link that.
Okay. And then, like, if you want to keep that directory, but then remove it as an origin. So say you're someday removing that Sunday directory as an origin.
So let's say I wanted this to be PA4, right? So here's something I can do. I can say git remote remove origin. Okay, and that breaks the link. And now if I want to actually link this to PA4, I would be able to do that. Alright, but I got into trouble here because that repository already exists on GitLab. So easiest way out of this, right, just make sure you have your files on your Linux server, get rid of the repository on GitLab, and then when you do this git remote add and this git push, it'll create the repository. And if you just want to get rid of everything Git related to it, you can just remove the .git directory. And that wipes out all your local history of changes and so on. It doesn't affect your files that you actually have here. All right, if you want to know if your repository is intact or you want to pull your files from the repository, easiest way to do that. So here's my home directory, for example. You can do this from any directory you want. Git clone git add gitlab.com :username name of the repository. And it'll say cloning into PA4. It'll create a directory with that name. So there's a new directory, PA4, on top of pick. And if I go into there, that's got whatever was in the repository on GitLab. So you can pull the repository back to your local system.
Oh, so it means download the project and GitLab to your computer.
Yeah, so git push origin master pushes from your local system to GitLab. Git clone pulls from GitLab back to your local system.
The same name as the name on GitLab.
Yeah, so I used pa4.git. That's the name of the repository on GitLab was pa4. And it creates a directory in my current directory named the same thing, pa4.
So the current directory before you could not have that PA4.
So my current directory now has a new directory in it called pa4. Right, it's a subdirectory.
I mean, before you do that, in your current directory, you cannot have a PA4 there.
I think if I try to do this again, I don't know if it'll just merge it in or if it'll complain. Yeah, so it already exists and it's not empty, so it'll complain. So if you want to keep PA4, move it out of the way, and then clone again. And then you can compare the files or do whatever you want. You always have like ultimate control if you're sitting in Unix, right? You always have access to your files. You can look at directories, create directories, rename things, move things, delete things. You have absolute control if you know, a kernel of Linux commands. And so if GitLab is being weird to you or doing things you don't understand, right? To me, the goal is let's just make sure that we have the files that we want, right? That's the first thing. If you want to preserve the history, that's the second thing. But mainly make sure you have the files that you want, and you can always just sort of wipe GitLab and start over. Worst case, but usually you shouldn't have to do that. Now, if you're pushing from two different machines to GitLab, this can start to get you into issues. If you push from machine A and then you push from machine B, but you didn't pull down what you pushed from A first, you'll get complaints from GitLab. And so you can say git pull origin master to pull down the latest version of something. But if you're doing that, you probably know what you're doing, and if you're not quite sure, ask me. But for us, we're mostly just using GitLab as just push things over there. A, so that they're an emergency backup, and B, so I can download them for grading, as opposed to synchronizing different machines there. Alright, now I got some random repos at GitLab. I'll try to figure out what they are later. What's this? Alright, other questions?
Oh, can I talk about that remove? So it removed from your computer or removed from the GitLab?
So RM is a Linux command. It's just removing on Linux. If I want to remove a file from a Git repository, I can say git rm, and that'll remove it locally and on GitLab. Or if I want to rename, I can say git move mv, and so on. But rm is just a local command. I just deleted those two directories, PA4 and PA4 old, just so I don't like trip over them later. Oh good, I'm still logged in. Alright, so let's get rid of these just for practice. So I clicked on the project name, I clicked on settings, and I'm going down to advanced, and I'm going down to remove project, and it says type PA4 and confirm, and that's gone. Or not. You gotta load computer. What?
They did better than you expected.
Yeah. Alright, let's look at my projects. Come on. Oh, now it's just being slow, I think. Alright, let's get rid of this. Okay, and then for some reason you always have to refresh this. Alright, so I got rid of all of those. I'm going to get rid of more of these later. Alright, let's talk about the midterm. So possible midterm topics. So midterm is on Friday. Don't miss your midterm. So there's a programming section and there's a Linux section. Okay, Linux section is 20 points. 4 programming questions, 20 points each. Okay, Linux. I'd like you to know basic commands like echo, cat, ls, change mod, move, copy, remove, word count, date, things like that. Make dir, current directory, print working directory, cd for changing directory, and so on and so forth. Hopefully stuff you've been doing in your day-to-day work on Linux. 2 C programming questions, 2 scripting questions. Okay, so Yeah, know how to compile C programs. That'll be useful. So gcc-o output file name and then source file or source files is the minimum to know. Variables, you can say variable equals some expression and the variable is equal to that. If you want the value of a variable, put a $sign in front of it. Right? Echo is good for output, read is good for input. Evaluating expressions, $sign paren, and then you can do, x plus y, and it'll evaluate x and y and add them together, that kind of thing, which is more related to bash programming. So bash programming, $! First line of the file, which almost everybody got on homework too, so good job. $! Followed by anything else is just a comment. Although $! Number is not a comment. $! Number is the number of arguments to the script. $1 is the first argument, $2 is the second argument, and so on. And remember, it's slightly different from how it looks in C. Alright, so that's a test script to see what $! Number and $! 1, 2, 3, 4 is. Alright, so if I say script name, this is a test, then $! Number is 4. Okay, that's different from C. If this was a C program, argc would have been 5. Okay, slightly different, really important. $1 is like argv bracket 1 is the first command line argument. $2 is the second is, 3 is a, 4 is test, that's the fourth command line argument. So the $! 1, 2, 3, 4 works like argv bracket 1, 2, 3, 4. Okay, but $! Number is not exactly argc. It's actually argc minus 1. And $0 is something special. No, it's not. $0 is like argv bracket 0. So that's exactly like argv. It's just $! Numbers argc minus 1. All right, variable assignment. Variable equals something. No spaces anywhere. You can use quotation marks if you want to group things together that have spaces embedded in them. Double quotation marks still evaluate $! Inside though. Know how to do an if statement, an if-then statement, and an if-then-else statement. Okay, and I do care about syntax. So for ifs, it's if space bracket space condition space bracket new line then new line body of the then clause. And then either fi for end of the if, or else if you want to follow it by an else, or elif, elif if you want to follow it by another if statement. Elif space condition in brackets, new line then body, and then either a phi or an else or an elif. Alright, so just make sure you know that, and there's examples in that cheat sheet on Canvas, or write some code and just put some samples of it on your note card. I want you to know while loops. Okay, I'm not going to ask you about for loops, but I want you to know while loops. So while bracket condition, do body of the while loop, and then done to be the closing bracket. Variable assignment, just variable equals something. $! Paren evaluates an arithmetic expression. Read is for input, echo is for output. Make sure you know how to do conditionals. Right? It's expression equals expression or greater than or equal or less than and so on. These are for numbers. expression equals expression, or not equal to expression. These are where you're just comparing strings. Right? Pretty much everything is a string anyway, but if you wanted to treat it like a number and say which one's bigger, use the dash EQ, dash not equal, and so on. And be thinking about algorithms. I'm not going to have terribly complex algorithms for you to figure out on the fly, but pretty straightforward things, hopefully. All right, C programming. You should know all the basic syntax. You should know how to make a main program, how to declare a function, variable assignment, variable declarations, integer this, character that, if statements, for loops, while loops, all the basic syntax, right? Characters, okay, things in single quotes or something defined as a car space, such and such. Arrays, so if you want an array with storage, you say something like, you know, integer data bracket 100, or character name bracket 30. Right? It does three things. It declares a variable of a certain type. It says it's an array because it's got brackets, and it sets aside space for a certain number of those things. So this is a full-blown array of 100 integers. It does not initialize it though, right? I don't know what the value of data bracket 0 is unless I give it a value somewhere. But it says it's an array of integers and I want space for 100 things. That actually creates a chunk of memory somewhere, allocates it to this. If instead I do this, integer star data, or character star name, well, it makes an array. It tells it that it's going to be an array of characters or integers, but it does not allocate memory for it. If I try to access data bracket 0, I'll probably seg fault. Okay, so that's the two sort of main ways we set up arrays. Allocate space for it like in a main program, or just say this is pointing to an array of integers, like in the argument of a function, for example. All right, strings are particular types of arrays. They're character arrays. They have a null terminator at the end. The character whose ASCII code is 0. It's just the value 0. But as a character, it's single quote \0. And that just gets put at the end by convention, so that things like printf, string length, and so on know where we want the string to end. Otherwise, is a string 2 characters or 100 characters? There's no way to know. So it's just a convention. All right, main program, argc, char star star argv. Make sure you know what argc and argv do. If you don't, write some code. It's really good practice. Write a main program with argc, argv, and just start looking at the values in there. Right? If you get a seg fault, try to figure out why you got a seg fault. Don't just try to get rid of it. Try to understand what's causing that seg fault. Once you understand that, right, you probably won't get a seg fault from this again ever. So argc is the number of things on the command line, including the program name itself. So stick 200, argc is 2. Stick 200, 2 things. argv bracket 0 is stick, argv bracket 1 is 200. All right, so argv is just the array of those strings on the command line. Yes?
So like, what is a segmentation fault?
Segmentation fault is basically trying to access a memory location that you don't have access to. Either you're trying to read something that's unreadable or write something that's unwritable. Because old memory was broken into segments because we had this legacy Intel processor that only handled 16 bits of addresses. And so to handle more than 64K of memory, they started breaking memory into segments. And you could say, okay, I'm working in this segment, and then your 16-bit address would be within this chunk of memory or that chunk of memory. And then protections got added, and this segment was accessible, and this was readable only, and this had no access. And so if you tried to touch a segment you didn't have access to, you got a segmentation fault. That's my recollection of it, at least. Yeah. All right, so if we know that argv bracket 1 is 200, right, the number of sticks we want to play with, and we want to put that in a for loop so we can print out a list of 100, 200 sticks, right, we need to turn it into an integer, because we can't say for I is less than a string, right? So scanf mainly lets us do things like convert strings into integers. Okay, but it could convert a string into a float or a double, or it could convert an integer followed by a character followed by an integer into a pair of integers and a character, right, like RODP. So scanf lets us do all of that stuff. And we have to give it three things. We have to give it the string that we want to reinterpret. That's the first argument. And then we have to tell it how we want it interpreted. That's the second argument, %d, %c, %d, or %d or whatever. And then the third argument on is the list of variables we want to write the results into when it's done this interpretation. Printf is the other direction. We want to take things like integers and basically turn them into a bunch of characters and display them. And so we use %s, %d, and so on. Gets just never use, right? fgets lets us read input from the user. So tell it where to store the user input, how many characters you can accept, and then where you want to read from, which for us is just standard in. And the program basically stops, waits for the user to hit enter, and then everything they typed up to and including the enter gets loaded in that string. You should know how to write a function, call a function, return a value from the function, right? And you've been doing this like daily, basically with ODPs. And again, you know, think about algorithms, but nothing too fancy algorithm-wise. All right, good. 2 C programs, 2 bash programs, 12 Linux questions, 8 Git questions, and you're done. All right, so that's Friday. We got time. Think about these, ask questions, write some test code, play around with it, and we'll talk about other stuff tomorrow. All right, I'll see you tomorrow then.